There we go. So today, this is our sort of introduction to our wireless lineup. We've got a lot of different access points out there, and we've got some different technologies that maybe some of our competition doesn't have. So we've put this webinar together to sort of give you a high-level overview of the products that we have that are available, some of the differences between them, give you some ideas of what's there, and to answer some of the questions people have been having. So to begin with, we've really got three lines of products, or three different categories of access points. We have a line of SOHO products, which aren't shown here on this slide. Those are products that have just two numbers or two digits in the model name, something like the NWA 50AX or NWA 90AX. We will talk a little bit about them later, but the two main products that are aimed here for our channel partners is the Flexible Series and the Ultimate Series. So the Flexible Series are going to be those products that have 3 or 4 digits in the model name and start with 1 or 2. And the Ultimate Series are going to be those products that have 3 or 4 digits in the name and start with 5 or 6. So some examples on the flexible side of things: NWA 1123 ACV3. It's got 4 digits in the model number there. It starts with the number 1. NWA 210AX, 3 digits in the model number, starts with the number 2. And then on the Ultimate Series, examples of this would be the WAC 6103D-I or a WAX 640S -6E. So the main difference between these two series is the Flexible Series can be managed directly, through a web GUI or SNMP, or you can use our free Nebula cloud management platform to manage them. Going up to the Ultimate Series, in general, it gets you some extra options as far as antenna technology goes. Can be managed directly, can be managed with our free Nebula cloud. It can also be managed using one of our security gateways that have built-in wireless LAN controllers. So if you're looking for local coordinated management, Ultimate Series is what you're looking for. And the Ultimate APs all include 1-year Pro Pack, which is an optional license for our free Nebula cloud platform, which unlocks some additional features. So we'll talk a little bit here about the hardware itself, because our hardware is different than most of our competition. In the pre-COVID days, we used to bring around some of our access points and some of our competitors' access points, a Ubiquiti, a Ruckus. I think we even had Meraki for a while there, and let you take a look at them and see the differences. So one of the first things you would do is we'd have you pick them up, and you would feel that our access points were heavier than our competitors. And then we could open them up and show you what's inside. So this is just showing you here what's inside most of our access points, even our cheap little $79 1123 ACV3. So these are solid state products. So all of our access points here that are part of the SMB lineup here, the Flexible or Ultimate Series, all come with a lifetime warranty, where a lot of our competition, especially on the lower end models, is only coming with a 1 or 2-year warranty. So one of the major causes of failure on a solid state electronics like this is heat fatigue. Basically, heat builds up over time, temperatures changing with use can cause solder joints to fail. It can even cause the little switches that are part of your microcontrollers to fail over time. So all of our APs are going to have this large metal heat sink that goes between the PCBA and the housing. And it's designed to draw that heat off the PCBA. And then we've got a bunch of vent holes there to vent the heat out of it. If you look at some of our cheaper competitors out there, you will see it, not only do they not have any sort of heat sink to pull the heat off the components on the board, some of them don't have any air vent holes at all. So that's why they'll have a shorter warranty on them. Another thing we do to help extend the life of the products is we don't use any electrolytic capacitors. We only use solid state capacitors. So electrolytic capacitors, for those of you not familiar with them, are filled up with an electrolyte, essentially salt water, that helps them do their job, as well as a little cloth material in there. So those can leak, they can dry out, they can boil over, they can burn up. So we've eliminated those and only use solid state capacitors, which again allows us to extend the life and allows us to offer that lifetime warranty on these access points. And then when it just comes to performance things, we have a sort of RF first design philosophy. So in addition to this standard RF shielding you'll see on everybody's access points on the components on the board that are designed to protect against EMI, we add additional shielding specifically designed to filter out 4G and 5G signals. So some of those 4G and some of those 5G signals are on frequencies that border the Wi-Fi signals. And in particular, if you're dealing with a large apartment building or an office building where they're using a DAS system to bring cellular coverage into the building, some of those signals can be really strong and can easily bleed over into the Wi-Fi space. So our shielding helps prevent that from causing interference to your Wi-Fi. And then the other thing we do is we generally do not put the antennas onto the PCBA like most of our competition, including some of the more expensive competition. It adds a little extra cost. It makes the products a little bit bigger, but it provides greater isolation between the antennas and any sort of EMI that might be on the board. We also have the ability to use a noise spreader here to help reflect some of the signal back to give us a little bit of boost. It's not going to give you a big difference as far as general range or coverage goes, but this little bit of difference that you get by moving the antennas off the PCBA onto their own board really helps you out on those marginal cases, those users that have a low quality connection. It's the difference between something that's barely usable and something that's slow but solid and steady. So one of the technologies we have that's a little bit different than our competition is something called dual optimized antennas that are available on certain access points. So your traditional Wi-Fi access point has been designed to be mounted on the ceiling above the area to be covered. And so the antennas that are built into that access point have been optimized based on that use scenario. So they create a sort of umbrella type coverage pattern, which radiates out and down from the access point for coverage. The problem is out in the real world, you don't always get to mount your antennas, or excuse me, your access points on the ceiling. Sometimes you end up having to mount them on the walls where they're rotated, right, 90 degrees from the orientation that they were designed for. And so because of this, you get a less than ideal coverage pattern. You send a bunch of your signal up into the ceiling or down into the floor. So our solution for this is something called dual optimized antennas. So on our access points that have dual optimized antennas, we have two different sets of antennas. One that's your traditional ceiling optimization, and then a second set that's optimized for wall mount. And then you can simply go into the software or into the Nebula cloud, and you can tell it which antenna pattern to use based on where you've installed that individual access point. So your ceiling mount APs have the ideal coverage pattern. Your wall mounted access points also have the ideal um, antenna pattern from where they've been mounted. The other technology we have is something called smart antenna. So smart antenna technology is something that pretty much it's just us and Ruckus that offer this. Ruckus calls theirs Beam Flex Plus. We just simply call ours smart antenna. And smart antenna has been designed to help maximize coverage area, but our algorithm and our way of doing it has been optimized to deal with interference, whether it's from other access points or other devices. So I'm going to take a few slides here to talk a little bit about Wi-Fi RF in general. If you want to know more than what I go into here in these next few slides, we do a Wi-Fi 101 webinar every now and then where I really dig into Wi-Fi and how it works a little bit more in depth, and we go into this a little bit more in depth. But just to start with here, just in general, when it comes to RF, there's some exceptions here when it comes to things like MU-MIMO, but in general, when it comes to Wi-Fi and radio transmissions, one device transmits at a time on the same channel. You cannot have multiple devices transmitting at the same time using the same channel, or else you run into interference issues and drop packets. Anybody that's been on a road trip where you're driving out in the country and you get into that situation where you're sort of between two different radio stations on the same or similar channels and they start overlapping and it just becomes a mess of noise. It's the same thing that happens with your data packets. Or if you're old like me and remember the old analog walkie-talkies, when you and one of your friends tried to talk at the same time, the third person would just hear a bunch of distortion and garbage. And it's basically the same thing that happens with Wi-Fi. So when it comes to the 2.4 gigahertz spectrum, we have roughly 60 megahertz of bandwidth that's available. And that bandwidth has to be shared between any sort of 2.4 gigahertz device operating. So all your Wi-Fi devices, all your Bluetooth devices, any other sort of wireless device that also uses 2.4, your kids' RC, car, things like that. So when you first look and pull up a GUI of any sort of router or access point, you'll think, hey, there's a lot of channels to choose from. You will see here in North America a choice of 11 channels to use. The problem we run into is that the actual bandwidth being used by a channel in Wi-Fi is 20 megahertz in width, whereas the channels themselves that you see there are not spaced out anywhere close to that. And again, remember, we only have roughly 60 megahertz total available, but your Wi-Fi device has to use a minimum of 20. So what that means is basically as soon as you have 3 different access points or routers in an area, you are going to have overlap issues because those channels will have to overlap. There's only 3 non-overlapping channels to choose from. Now, all the way back when we came out with 11N, one of the ways that you got that big speed increase from G to N was by doubling the bandwidth the channels use. So what they did is they said, hey, instead of using 20 megahertz to do Wi-Fi, let's use a 40 megahertz wide channel to do Wi-Fi. So of course, the problem you have there again is that there's only around 60 megahertz of channel bandwidth available. And now you've got a single device using 40 of it. So as soon as you add a second device that's also trying to use a 40 megahertz channel, you have overlap and you have interference. So the next step up from that was, well, let's move people to 5 gigahertz. And this is why, 5 gigahertz really started to get pushed in the later days of 11N and became, de facto standard with 11AC that anything you bought had to have 2 radios, a 2.4 for your older legacy devices and a 5 gigahertz radio for your newer products that you have in your home or your business. And the reason for that is because the 5 gigahertz spectrum has a lot more channels to choose from. So if you see up here, these are 20 megahertz channels, and we've got over 20, it's 26, but over 20 non-overlapping channels that you can choose from. So now you can have a lot of devices, a lot of access points in an area, and you don't have to worry as much about the channel overlap. Now you will notice here in the middle, there's a big number of these channels that are highlighted in sort of an orange color, and it says DFS channels. So part of the problem we ran into with the 5 gigahertz spectrum is that before the FCC opened it up and said, hey, you can use it unlicensed, it was being used as part of a chunk of licensed spectrum where you had to buy a license to use it. And there were people that have been using it and have been using it for decades. One of the most common uses of at least part of that 5 gigahertz spectrum is the use of radar systems, whether we're talking weather radar or we're talking airport radar. They use parts of the 5 gigahertz spectrum. There's other applications that use other sections of the 5 gigahertz spectrum. So when the FCC opened it up, the people that already had licenses and had been using it said, hey, wait a minute, we're already using this. What about us? So the FCC solution was this thing called DFS. It was basically a rule that says, yes, you can go ahead and use Wi-Fi on these 5 gigahertz spectrum, but before you use it, you have to make sure there aren't any legacy users using that 5 gigahertz spectrum. And if you are using 5 gigahertz and suddenly you detect that there's a legacy user, you have to stop using it. So what happens is before you can start broadcasting, your access point checks and listens for a period of time, says, okay, no legacy users are using this channel, I can start using it. And anytime they detect a legacy user or noise that might be mistaken as a legacy user, they have to stop broadcasting and either back off until that usage goes away or change channels. And if they change channels to another DFS channel, there's a bit of a delay while it has to check again to make sure this channel isn't being used by anybody before it can start using it again. So for that reason, depending on where you're located in the RF environment you're in, 5 gigahertz may see more frequent disconnections than you would get with 2.4. Also, 5 gigahertz doesn't have quite the same range as 2.4 because the signals get degraded quicker. And another challenge with DFS is that it can add up to 6 months to the time it takes to get your product FCC certified. So in the rush to be one of the first to market, especially in the consumer space, some vendors will choose not to get DFS certified. So that poses a problem when you're in an environment where you're providing public Wi-Fi, or you're allowing your employees to bring their own Wi-Fi devices, is they may buy and bring a device onto your network that can't use DFS channels. So if you are using one of these DFS channels, they won't be able to connect, or at least they won't be able to connect to that AP that's closest to them. They'll have to find an AP that's not using DFS and connect to it. So it may have degradation. So for those reasons, what we find is in a lot of deployments, people choose not to use DFS channels. Just for the sake of making it simpler to troubleshoot things and making it so there's less complaints from the users. But of course, if you get rid of these DFS channels, you've gone from 20 plus non-overlapping 20 megahertz channels, and now you're down to just, what is it, 8 or 9 non-overlapping DFS channels. And again, part of the ways we've gotten faster is we've gotten to wider and wider channel utilization. So as I mentioned with 11N, we moved up to 40 megahertz channels. So if you're using 40 megahertz channels on your network, you've now only got 4 non-overlapping channels that you can use that are not DFS. And then with 11AC, they introduced 80 megahertz channels. So now you've only got 2 80 megahertz channels you can use before you start running into interference issues, as long as you're avoiding DFS. So now we're almost back into the same situation we are with 2.4. You've either got to reduce your speeds by using smaller channel width, or you end up with some potential overlap issues with your access points and are back to trying to figure out how to stagger your APs to not interfere with each other. And then 11AC Wave 2 and Wi-Fi 6 are using 160 megahertz channels, which have to use DFS to be able to use them. So the point of all of that is, if you're in an apartment building, a condo, you're in an office building where there's multiple floors, there's multiple different companies with offices around where you can't control their network. If you're trying to run your APs at full speed, which is the default setting for most devices when you take them out of the box, you may run into these interference issues between the individual access points and the users on different access points. And again, we go into this a little bit more detail on the Wi-Fi 101 webinar. But anyway, those are sources of what we call code channel interference. So one of the big benefits of our smart antenna technology is the ability to solve these code channel interference issues. So here's just sort of an example. Here's your traditional single antenna pattern AP. It's mounted to the ceiling, and then you introduce a source of noise. In this case, it's using that same frequency that you're using. In this case, it's a microwave. So this is a 2.4 radio, but it could be another nearby access point. It can be any sort of wireless device that is producing and generating radio signals that are not part of your Wi-Fi network. And you get interference, and it degrades the quality of the connection, can cause disconnections, although mostly I think it just causes a lot of packet drops, really a lot of loss of stability from what I've seen out there. So by going to smart antenna, instead of having that one fixed antenna pattern, with smart antenna, we've actually got not just the one of a standard AP or 2 different sets of antenna patterns like with our dual optimized antenna. With smart antenna, you've got hundreds of different antenna patterns that you can use. And so our access point will go through in nearly real time and choose the antenna pattern that both optimizes the signal strength, directing it towards the direction of the client device it's communicating with, but also by ignoring other sources of noise. So because of this, with smart antenna, you can have more access points in an area operating without interfering with each other. You can have more users on the same access point without having to suffer from some of those interference issues that you run into otherwise. So this is just showing here a test we did. We took our WAC 650S, we took the equivalent Aruba product. Both are 4x4 Wi-Fi 6 access points. Ours has smart antenna, Aruba doesn't. And you can see here our throughput's in green, theirs is in blue. It makes a big difference out there in the real world as far as performance goes. Now, a few years back, a group at the University of Brescia in Italy, they saw claims people like Zyxel were making and Ruckus were making as far as the benefits of smart antenna technology. So they decided to test it. So they bought one of our access points, they bought a Ruckus access point, and they bought a Cisco access point and an Aruba access point. Cisco and Aruba don't have smart antenna technology. And they put them all through a litany of tests. So you can see there's a link down there that takes you to the networking group at the university there, and you can pull up the entire white paper they did, all the testing they did, and take a look for yourself to see, just what the benefits of smart antenna are. Did it live up to the hype? Just a quick summary, and basically in a real world environment out there where you've got other sources of RF interference and noise, significant improvement, up to 70% better performance with smart antenna versus without. And our smart antenna outperformed Ruckus's smart antenna. We do have a little white paper you can download that sort of summarizes the key parts of this big study group here that was done. And you just go to Google, type in Zyxel smart antenna, I think just smart antenna white paper, and it should take you to the landing page with a PDF you can download, as well as some graphics and stuff, which highlight the main benefits. So you can share them with your customers if you're trying to convince them to pay the little extra money to go up to smart antenna. So the next thing I wanted to talk about here is Wi-Fi 6 technology. We will also talk about Wi-Fi 6E in just a few minutes, but we'll start just by talking about Wi-Fi 6 because it's still relatively new. And just based on our sales, there's a lot of you that have not yet started selling it, or you've got customers that aren't yet ready to make the jump to Wi-Fi 6. So what is Wi-Fi 6? The short version is if you've sat through my Wi-Fi 101 webinar, you know there's a lot of sort of problems with Wi-Fi as it was designed back in 1999 versus how we've changed and are using it, and it just wasn't designed for the way we use Wi-Fi today. So Wi-Fi 6, also known as 802.11ax, is the first technology basically that solves some of these structural issues with Wi-Fi. Since Wi-Fi first came out in 1999, we've been doing stuff to improve the speed by, adding multipath utilization. We've added, doubling and doubling again and doubling again bandwidth utilization, but we've never really addressed as an industry some of these core flaws in the way Wi-Fi was designed. So Wi-Fi 6 goes a long way at solving some of those issues. It gives us a theoretical maximum speed of around 10 gigs over Wi-Fi. Obviously, assuming the access point and the client device both support that many spatial streams. Higher capacity, both increasing the number of users on one access point, but also reducing the interference between access points. You can have more access points in the same area. And Wi-Fi 6 is taking these improvements to both the 2.4 and the 5 gigahertz radio. 11AC and 11AC Wave 2 only improve the 5 gigahertz radio. So if you have an 11AC device, now called Wi-Fi 5, your 2.4 radio is still a 11N or Wi-Fi 4 technology. It's only by jumping up to Wi-Fi 6 now that we do have these improvements. Although I will want to warn you out there, there are some vendors and some products, as an example, some of the lower end Ubiquiti access points, where the Wi-Fi 6 has only been added to the 5 gigahertz radio. The 2.4 radio is still using 11N technology. So it's something to keep an eye on. All of our Wi-Fi 6, all of the Zyxel Wi-Fi 6 products have the Wi-Fi 6 technology on both radios. So some of the technologies that make some of these improvements better was the move from OFDM to OFDMA. It gives the access point a much more granular ability to chop up the available bandwidth and share it among different devices that are talking to that access point for a much more efficient utilization of the available airtime. And using something here called BSS coloring, basically adding some information to the front of packets to say who that's intended for, allows multiple devices to transmit at the same time to different access points using the same channel, and reducing the amount of interference you get by allowing them to know that they can ignore data traffic that is not intended for them. So one of the big areas where you see improvement here, we are talking about increasing capacity. So one of the problems with 11AC and older technologies is as you add more and more devices to that access point, the aggregated throughput that's shared by all of the connected devices actually drops. So you can see that here in the dark orange line right here. As you add more users, the aggregated throughput drops. And the reason for this just has to do, again, with some of those structural issues with Wi-Fi. It wasn't designed for a high number of users. It wasn't originally designed to coordinate any sort of who gets to broadcast when. So you basically have sort of a free-for-all as to whose turn it is to be able to send data back to the access point. So you end up stepping on each other's toes and the aggregated throughput goes down. With Wi-Fi 6, aggregated throughput stays relatively flat flat, regardless of how many users you have on there, assuming they're all Wi-Fi 6 client devices. And it's the same thing whether we're talking about one access point or two access points. So we have a dedicated Nebula webinar that we do every month. So if you're interested in Nebula, which is our cloud managed networking platform, join that. It's a 30 to 40-minute presentation that we go a little bit more in depth into what Nebula is. I'm not going to go any more in depth on it today than I already have, but I do want to talk about the fact that we do have local controllers for our wireless access points. We still have people looking for these, and they tend to get overlooked with how much focus we put on Nebula. So I did want to let you know we do have on-premise controllers. They're built into our VPN, USG Flex, and ATP series security appliances. Most of those devices have that built-in controller and will support a small number of APs out of the box. And then through licensing, you can unlock additional APs that can be managed. But it's very similar to Nebula. They offer all the same sort of technology you would expect to see in a managed access point, you know, using the controller to intelligently determine which channels to use. With our controller system, our APs will automatically find the controller on the network. You don't have to configure the APs and point them to a controller or put them in controller mode. They will find the controller automatically and allow you to enable it through the controller itself. Mesh technology, fast roaming technology, et cetera, et cetera. So now it's on to the hardware. Let's talk about the hardware. We're going to start with sort of our SOHO products here. So we have an NWA 50AX and an NWA 55AXE. One is an indoor product, one is a product that's designed to be used outdoors. They're roughly the same product otherwise from that. And the 50AX is only available through Amazon. The 55AXE is available through distribution. And these are AX 1800 access points. So 2x2 spatial streams in both the 2.4 and the 4 gigahertz radio. But these are missing some features. These are what I'm going to call Wi-Fi 6 Lite and Nebula Lite. So Wi-Fi 6 Lite, because it doesn't support all of the features that are available in Wi-Fi 6, our SMB products support all of those features. If it was up to me, I would actually market these and sell these as Wi-Fi 6 Lite. Unfortunately, our competitors out there who also sell products that are missing some features don't make that distinction. So we can't be the only guy making that distinction, unfortunately. But so it's missing like MU-MIMO. It can do downstream, but it cannot do upstream MU-MIMO. It has OFDMA from the access point to the client, but doesn't support OFDMA from the client back to the access point. And then on the radius side of things, it doesn't support MAC authentication. It doesn't support captive portal. It doesn't support layer 2 isolation. So for those reasons, that's why we offer or market these more towards a SOHO environment where you probably don't need captive portal, you don't need layer 2 isolation, et cetera, et cetera. So the next step above that is the NWA 90AX. So this is still sort of a SOHO product, but it is available for you through distribution. And I believe you do get your partner discount on these. So this would be sort of like the entry-level AP that I would suggest for our resellers that you should be selling. So again, it's an AX 1800 product. It's a Wi-Fi 6 Lite product, but it unlocks some of these additional Nebula features or just in general AP features that are much more commonly used in a business environment. So it does support radius authentication. It does support captive portal. It does, support layer 2 isolation. Going up from there is our NWA 110AX. Again, another AX 1800 product. So all of these that we've talked about up to this point are AX 1800 products. So this is the cheapest product we have that gets you the full Wi-Fi 6 feature set. And it also gets you the 100% full Nebula feature set. So it's got the captive portal, it's got layer 2 isolation, load balancing, dynamic pre-shared key, SSID NAT, so the ability to do AP-based NATing on certain SSIDs, SNMP, and our CNP Plus security service. This is also the lowest priced AP on the Wi-Fi 6 APs, which gets you the lifetime warranty on them. So the next step up from that, sticking again still with AX 1800 technology, is the WAX 510D. Very similar hardware to the NWA 110AX. The differences are you're getting dual optimized antennas instead of the standard antennas, and then Nebula Flex Pro. So it's coming bundled with a 1-year Pro Pack license and also supports that local built-in controller on our security appliances. So that's it for AX 1800. I gave them their own slide like this because obviously you've got 5 different APs, all are AX 1800, and it causes confusion for people as which is which and which should I be using. So now going through the rest of the product lines that are still available today, we've got the NWA 1123 AC V3. This is our 2x2 11 AC or Wi-Fi 5 access point, very inexpensive, lifetime warranty, so it's there for you. We still have the NWA 1123 AC Pro. So this is a faster than the V3, and it adds dual optimized antennas for you. This competes very directly with like the Ubiquiti UAP AC Pro. Should in fact actually probably be a little bit cheaper to buy this than the Ubiquiti, and you get dual optimized antennas, better warranty, free cloud, etc. Going up here on the Wi-Fi 6 side of things, we have the NWA 110AX, which we just sort of talked about on the slide a couple slides back, and then the NWA 210AX. So the 210AX is a 4x4, so 4 spatial streams on the 5 gigahertz radio versus 2 spatial streams, so double the 5 gigahertz speed. It also has a 2.5 gig Ethernet uplink port because you've got so much speed going through the Wi-Fi. It'll easily exceed 1 gigabit throughput. So we give you that 2.5 gig connection back to so your physical connection isn't what's limiting your Wi-Fi speeds. Jumping up now to the 5 and 6 series or the Ultimate series, our entry level access point here is the WAC 500, 2x2 11 AC product there for you. It's Nebula Flex Pro, so it's got that 1-year Pro license. This is also going to be the cheapest access point we have that works with our secure Wi-Fi feature that's available on our security appliances that basically turns an access point into a remotely managed VPN appliance that you can give to your users to make it easy for them to VPN back into the office. So if you're looking for our cheapest AP to do that, the WAC 500 is what you're looking for. And then we've got our WAC 6103D-I. Again, it's a little bit faster on the Wi-Fi, and it's got the dual optimized antennas built in there for you. Going up from there, we've got a couple different wall plate APs. These are lower powered, small form factor APs that have been specifically designed to be mounted to a wall plate. And their primary utilization is in MDU or MXU deployments like hotels, where you put one of these in the room. You have Ethernet that goes into the back of the device. There are Ethernet coming out of it. So you run one cable to the room, and then you've got other cables that can go out to your IPTV, to your IP telephone. And each of these includes at least one PoE pass-through port. So you can provide PoE power to, for instance, that IP phone, just all through that one cable that's coming into the room itself. The 5302 has an extra Ethernet port and has a smart antenna built in, whereas the WAC 500H is one less Ethernet port and no smart antenna. And then going up here to our Wi-Fi 6 products, we have the WAX 510D and the 610D. So very similar to the NWA 110 and the 210. Both are using dual optimized antennas. The 610 has got that 2.5 gig uplink port. Both of them come bundled with 1-year Pro Pack license and can work with our controllers. Step above those, our lowest priced smart antenna AP is the WAX 630S. So it's basically taking a 610 and adding smart antenna to it. And then we've got our flagship model here, the WAX 650S. So it's our fastest AP, 4 spatial streams for both the 2.4 and the 5 gigahertz radio. It's got a third dedicated scanning radio for DFS or using it for rogue AP detection. It's got a 5 gig Ethernet uplink port on it, and it's got Bluetooth built into it for Bluetooth low energy. And then on the outdoor side of things here, we've got our WAC 6553D-E. This is our most heavy duty outdoor AP. It's an 11 AC product. It has a heater built in for extreme cold environments. It can support temperatures down to, I think, -40. It's IP66 rated and uses external antennas. Below that, we have the 6552D-S. It's IP67 rated, but doesn't have the heater in it. And this uses a smart antenna, but it's a directional smart antenna. And these have been specifically designed for providing access at outdoor venues like concert venues, stadiums, or you can actually put 4 of these on the same pole to get 360-degree coverage. We use these a lot in RV parks, marinas, and places like that. And then we've got our outdoor enclosure here, this guy here. So this is an empty outdoor enclosure that many of our indoor APs can fit inside. So if you're looking for a cheap, inexpensive way of putting a couple APs outdoors for whatever reason, you can buy an inexpensive indoor AP, put it in this outdoor enclosure and mount it outside. And this outdoor enclosure will protect it from rain, as well as give it a slightly larger temperature range of operation that it can support versus otherwise with those APs. So that's it for our primary AP line. Now we're going to talk about Wi-Fi 6E. So Wi-Fi 6E is a new technology. It just got unlocked this year. Basically what it does is there is, again, previously for Wi-Fi, we were stuck with 2.4 or 5 gigahertz. Any other frequencies required a license from the FCC to operate a device on. Well, 6 gigahertz has been one of those spectrums that required a license. So the FCC has decided to open this up and allow unlicensed use for Wi-Fi access points. And the big, huge benefit of this is it unlocks a massive amount of spectrum. You might remember before, right, 5 gigahertz had a lot more spectrum available than 2.4. Well, 6 gigahertz has more spectrum available than 2.4 and 5 gigahertz combined together. So you get a lot more available bandwidth. As you can see here, you might remember before when we were looking at 5 gigahertz, oh, my mouse is acting weird, that we had 260 gigahertz channels or megahertz channels that we could use without overlapping. With 6 gigahertz and Wi-Fi 6E, we now have 7 6 gigahertz, 160 megahertz channels. So you can be operating your Wi-Fi devices at full maximum bandwidth and not worry about overlap with any nearby access points. Pretty much the only thing that's using 6 gigahertz is Wi-Fi, so you don't have to worry about interference from other devices as well. So there are some challenges though for using this 6 gigahertz spectrum. So one of the things we talk about in our Wi-Fi 101 webinar is as you increase the frequency range, it's easier to cram more data onto that frequency, but the range goes down. So 6 gigahertz has much lower range than 5 gigahertz. So because of that, you will need more APs to cover the same area. You won't just be able to swap out 5 gigahertz for 6 gigahertz and get the same coverage for 6 gigahertz. So that is something to keep in mind. Another challenge we have right now when it comes to 6E is due to lawsuits from the guys who are already using 6 gigahertz before this change, is you cannot use Wi-Fi 6E outdoors. 6 gigahertz is only right now in the United States available for use indoors. At some point, it is coming to outdoor use and it will require some additional technology to make it work so it doesn't interfere with the legacy 6 gigahertz users. So for right now, 6 gigahertz is an indoor only technology. And again, the range is going to be much less than what you see with 5 gigahertz. So that's something to keep in mind. So why would you want 6 gigahertz? Obviously, you've got all this extra spectrum. It makes it easier for you to cover high density environments, right? Such as your conference rooms, your expo centers, things like that, because 6 gigahertz allows you to have more APs in the same area and each one operating on its own unique chunk of spectrum. So you don't have to worry about interfering with each other. And also when you're talking about these high density deployments, or you're talking something like an office building or a condo, The lower range may actually be a benefit, right? You have less interference from your neighbors' access points bleeding over into your space. So that may be a benefit there as well. And then also just a more available bandwidth means you can use it for higher bandwidth dependent applications. One thing people talk about is streaming VR, rather than trying to build it into a headset like with the Oculus Quest, and being able to just have higher resolution streams, things like that. So now let's talk about the 6E access points that we offer. So our entry level 6E AP is this guy here, the NWA 220AX-6E. So it has two radios, a 2.4 radio and a radio that can operate either on 5 gigahertz or 6 gigahertz. We call that band flex technology, giving you that flexibility. You can deploy it today as 5 gigahertz, and later on down the road, you can switch it over to 6 gigahertz. Once there are actually a lot more 6 gigahertz client devices available. As it stands right now, you pretty much only see Wi-Fi 6E on flagship phones, like the higher end iPhones or the Pixel, the higher end Pixels like the 7 Pro, and some higher end laptops. You aren't seeing it on a lot of other devices. So, as it is right now, you probably don't have a lot of users that could take advantage of 6 gigahertz, but maybe down the road, you want to be able to switch over and support 6 gigahertz once there's more available without having to swap out your hardware. So BandFlex gives you that. It's also an easy way just to add 6 gigahertz to your existing network by adding additional access points. So the step above the NWA 220AX is the WAX 620D-6E. So again, same thing, it's that band flex. You've got a 2.4 gigahertz radio, and you've got a second radio that supports either 6 gigahertz or 5 gigahertz. The benefits of the WAC over the NWA is you get the dual optimized antenna technology, you get support for that local wireless LAN controller, and it comes bundled with 1 year of the Nebula Pro. And then this guy here, if you're looking for something that does both 5 gigahertz and 6 gigahertz at the same time, you want to take a look at our WAX 640S-6E. So this is 3 radios. The 6 gigahertz radio is 4 spatial streams. The other 2 radios are each 2 spatial streams. It has our smart antenna technology built into it. So this is what you'd be looking at there. So that's it as far as our hardware goes. And now we'll talk briefly here, a few slides here on some of how we stack up with some of our competitors. And then we'll be done. And again, if you guys have questions, you can send them in using the question and answer interface in Zoom, and I will see them and get to them here at the end. So I just did a couple of these comparisons here. Just to let you guys know, if you're here, you're probably a channel partner of ours. You're part of our partner program. You've got a salesperson, either Andy, David, or Jacob. We have some comparison documents that we can give you, including both those that show our whole lineup of APs and make it really easy to see what the differences are between them, as well as some competitors comparisons. So reach out to those guys and ask for them, and they can give you those as PDF downloads. So you don't have to remember all of this. But here, we're taking a look here at what has historically been the best-selling space when it comes to business Wi-Fi, which is the 3 spatial stream 11AC product. Probably the best seller in this space here is this UAP AC Pro. So this compares with our NWA 1123 AC Pro. So the differences here between these, we've also got Cisco and D-Link in here. As you'll see here, we have much higher output power than our competitors do, 27 dBm versus 22 on the Ubiquiti, 22 to 23 here on D-Link and Cisco. So much higher output power, more SSIDs can be broadcast versus Ubiquiti, dual optimized antennas versus just the static antennas on the Ubiquiti, support for SNMP V2C and V3 versus just SNMP V1 on the Ubiquiti, support for our free cloud, and then also lifetime warranty versus 1 year warranty. And again, the prices should be roughly the same for you to buy these. So yeah, great comparison here as far as using the NWA 1123 AC Pro versus Ubiquiti's UAP AC Pro. We'll jump up here to one of our Wi-Fi 6 products here, the WAX 510D. And we're comparing it with an Aruba AP505 and Ingenius's products. So again, same thing. Both of them are going to be the same configuration as far as the Wi-Fi 6 goes, same number of spatial streams, same number of radios. Ours offers that dual optimized antenna where our competitors do not. Again, you see higher output power, 23 and 26 dBm versus 21 and 20 dBm on our competitors. This is a full Wi-Fi 6 product where the Ingenious product is a Wi-Fi 6 Lite product. It is missing some of those key Wi-Fi 6 features. And then we've got our free cloud for you to use. So that's where we stack up there. And then lastly, we'll just do a quick 650S. So this is our flagship AP. This is showing our competitors here. Probably the biggest ones for you guys are going to be the Meraki MR45 and that Ruckus R750. So again, Wi-Fi 6, 4 spatial streams, same across the board on the antennas. Once again, we've generally got higher output power than most of our competition here, 28 dBm versus 23 and up from our competitors. We've got a built-in monitoring radio, something that's missing from the Cisco, Aruba, and Ruckus APs. We've got that 5 gig uplink port, something that only the Aruba has. Most of our competitors there are just using a 2.5 gig uplink. Then, of course, we've got our free cloud there. So that's how we sort of stack up for you. And that's it as far as today's webinar goes. Again, if you have some questions, go ahead, send them in using the question and answer interface. We do have a YouTube channel. There's lots of Zyxel YouTube channels. The one here for North America is called Zyxel America channel. And in addition to having things on there like our video case studies and success stories, it's also where all of our webinars get archived. So today's webinar will get archived and put up there within the next day or two. So you can always also go back through and find previous versions of the webinar on there, share them with your friends. And then you can always like us on LinkedIn. We are there as Zyxel US channel. I haven't had any questions come in, so while I wait to see if anyone else is maybe working on something, I also want to point you to our forums, forum.zyxel.com. These are user forums that are also monitored by our headquarters, by our R&D and our product management teams, so they do see your feedback on there. Occasionally, they will jump into threads and answer questions you may have. These forums are also the first place generally where we post up security alerts, firmware notes, and things like that. So be sure to check them out. No questions have come in, so I'm going to go ahead and end today's webinar. Thanks for joining us, guys. I appreciate you turning out.